in order to understand the basics of electricity, you got to kind of know a little bit about an atom. In an atom, you have positively charged things. We call these protons. They're basically just positively charged particles. Those are located in the nucleus. If we look at an atom, they're the ones that are here in the middle. They're all kind of stuck together in a ball. Nucleus actually means little nut, because it's a little tiny thing in the middle. So these are the protons. And then whizzing around here, all at once, are these little tiny electrons, like these little white beads. We'll call those electrons. Now, here's the thing. These electrons really like these protons. They like to, boom, they attract each other. This is positively charged, this is negatively charged, and they attract. We say opposites attract. They pull together. You probably learned that maybe in 3rd grade when we talked about invisible forces, on how charges attract each other. We also probably learned that if you had 2 negatives, 2 of these little beads, they actually, they repel. They don't like each other. We say that opposites attract, likes repel, which is why it took me so long to get married. So 2 protons then would actually try to repel each other. They would try to get as far away from each other as they can. However, they are stuck in the nucleus. They're kind of bound in the nucleus. So, what's this have to do with electricity? Well, we know that in an atom, the protons are here and this electron's whizzing all around. So this electron's able to move. It's able to move from one atom to the other. In fact, it does that in a conductor. So what a battery does is a battery takes a lot of these electrons. Now, this side of the battery we would say is positive. It's got all kinds of cool positive stuff over there. Of course, there's a couple of electrons. I'll throw a couple of them in here. But the point is, there's more positives. There's like 12 or 13 positives, only 2 or 3 electrons over there. It's 2 or 3 negatives. So this one's net positive. It's got a big positive charge. And then over here, we put all of the electrons, the negatives, they're up in here. And the battery, the key to a battery, is it separates these two. It puts the electrons on one side, it puts the protons with a positive charge on the other side. That's the idea behind a battery. Now, our batteries, our regular batteries that we use, are actually, they use a chemical equation. They use chemicals in chemistry to pull these electrons to the other side. So that's what puts these electrons up here. So then what we do is we actually put a wire that connects one side of the battery to the other side of the battery. We give them a path to move. And if I connected these with a path to move, these babies are just going to start whizzing right over there, aren't they? They're just going to go right over to the other side. That is electricity. As these charges move through our wire, we actually make them do things like light our light bulbs and make our PlayStations go. All the things that we want electricity to do is because we have connected the negative side to the positive side, which then these get pulled down there. So, a couple of things about electricity. If we were going to look at the current in electricity, the amount of current, we would just need to know how much charge is flowing through here every second. How much charge is moving through? Resistance is another part of electricity. Resistance is actually how bumpy of a road it is. If I go through that and kind of squeeze it a little bit as it goes through, it kind of slows things down. We put some bumps in the road. Maybe I open this thing up here and put some, like, make it rough on the inside, so it's not as easy to go through. That would be what we call resistance. So current, the amount of charge going through. Resistance is how much we try to impede or stop that charge from going through. The last piece of electricity is what's called voltage. Voltage is kind of the energy that each electron has, the push or the force that we push each electron. You can imagine it this way: if this electron is kind of gently going through like that, or is it a big fall from way up here all the way down? How much did that battery separate them apart? What is that push of each of those charges as they go through? We can actually look at this another way using water. Another way we often model electricity is with water. We think about the word current, and if we ran some water through this hose, the current, you could imagine the current being the amount of water that's moving through here every second. If I stop right here and counted the particles of water, or even the gallons or ounces of water that are going through here every second, we would call that the current, right? The resistance of the movement of water would be how thick the hose is. If I twist the hose a little bit, I'm going to put some bumps in the road and not allow the water to go through. But the hardest one is the voltage. The voltage is how much energy that water has, how much of a push, how much of a force each of those particles of water has as they move through here. So the example of that, if I had this on very, very slow, we get a little bit of current coming out of here because they don't have a lot of a push. There's not a lot of pressure pushing them down the hose. But if I put it on a lot heavier, now each of those particles has a lot bigger push. That water is being pushed through. We think of the same thing with electricity. The current is how much charge is moving through a wire. The resistance is how much of a conductor or how much of an insulator that wire is. If it's a conductor, there's very, very low resistance and the electricity or the charge just moves right through. If it's an insulator, it has some bumps in the road that kind of slow the thing down. And finally, voltage. How much of a push are we giving those charges? Do they really want to get to the other side, or do they just kind of want to get to the other side? And that has to do with the difference in the top of the battery or the bottom of the battery. How many electrons or how much charge do we put on that side? Do they really get a push off, or do they just kind of get a push off? So you can model that with water when you think about current, the pressure, the push of the water, and then of course the resistance inside the tube. Now we said that batteries use chemical energy to convert it into electrical energy. They use chemistry, the idea of mixing chemicals together and forming new bonds in order to separate those electrons from one side of the battery to the other. You've probably witnessed this if you've ever seen an old battery. You want to be very careful with old batteries because the chemicals that are inside are actually corrosive and they're not very good for you. So I'm going to definitely wash my hands when I'm done with this. You can see that this battery actually is not terribly old, but old enough to start to get some corrosion on the bottom. We have positive side up here, the negative side down here. The chemical reaction on the inside pulls the negatives to one side, keeps the other side positive. So when we put a wire, that's what discharges the battery. That's really the reason why batteries only last a certain amount. Once those electrons have moved, then the battery is no longer good. I have a 9-volt battery here that's pretty old. It's been stuck in something. This is actually the positive side here, the smaller part of the 9-volt. This is the negative. So the current comes, out of the negative, the electrons come around there, and then they go into the positive. But you can definitely see there's some corrosion going on from that chemical reaction that was happening on the inside. Is actually starting to leak out on the outside. You feel the bottom of this actually bowing out a little bit. Here's a really bad Duracell battery that I got out of a really old calculator. You can even see the knob thing at the positive side up here. You can't even see it because there's so much corrosion happening. This is not good for you. I'm definitely going to wash my hands when I'm done dealing with these things. This is also another reason why we don't throw batteries away. We always want to recycle them because some of these chemicals are not good to be in our landfills. We prefer to get those in a controlled environment where we can recycle the batteries into new things. So you can see the chemical reaction that's happening. Batteries take chemical energy and turn it into electrical energy.